You can see it here in the AISC Steel Frame Stairway Design Guide. You can also find them here in FEMA's Component Design Guide, which is their publication E74 if you feel like looking it up. This is another slotted connection from that same FEMA design guide. And I have seen these kind of connections dozens of times during my 8 years designing steel stairs in California. However, the question may eventually become, do they work like we want them to? Hello and welcome. I'm told that if you want to produce videos on YouTube, you should find a specific niche and target that audience. And if you're going to do that, it doesn't get a whole lot more niche than steel stairs and their slotted connections in California. So for all 12 people who are going to end up watching this video, welcome. I don't know what's wrong with you, but, well, we'll see. This is what I'm doing for right now. We'll see if it was a good idea later. Before we get started, let's get some initial questions out of the way. Why do engineers include these slots in their designs? The first reason is to accommodate what we call interstory drift. And that's the idea that in an earthquake, the floor above and the floor below are going to move relative to one another. Despite what most people think, when engineers design buildings, we don't actually design them to survive the big. We design them a little bit like these impact attenuators that you might find on the freeway. There are portions of the buildings that are designed to bend and deform and deflect during the big one to safely dissipate that energy. And in the process, the floor above and the floor below are going to move relative to each other, and that's what we call interstory drift. Some buildings will move as much as, and this gets technical, as much as 2.5% of their height. So if you have a 12-foot story height, and that's 12 feet from one story to the next, which is really a common height in commercial buildings, and you have 2.5% movement on each side, that's 3.6 inches to the left, 3.6 inches to the right. That's over 7 inches of relative displacement. And when you add in a 3/4 inch diameter bolt, you now have an 8-inch long slot that you might need to allow for that interstory drift. So that's where you'll see these connections with 8-inch long slots. The second reason, and arguably the more important reason that we include slots in our designs, is that it's required by the code. Unless this code exception is met, and you've included the stairs in your overall building structural model, then these requirements apply. Often, the preferred method of meeting these requirements is to include the sliding connection with oversized slots, as shown here in Part A. So you follow the code, you design your stairs with slotted connections. In your structural model, you release the reaction forces from the nodes parallel to the slots. You rerun the model for the 10 millionth time, you take a drink of coffee, and life is probably not so bad. But does it actually work that way in reality? Is there actually no resulting force in that direction? As an industry, we've all been reading these code requirements and adding slots to our designs as required, but to my knowledge, and I've done a bit of looking, these connections have only been reviewed in one paper that's been so far published. There is another full-scale structural model that was just done in, I believe, San Diego. Don't quote me on that. And I believe that it did also include slotted connections, but that research hasn't been published yet. So I'm looking forward to those results. However, in this paper published by Black in 2020, details in the comments, they include some really interesting stair configurations and conclusions. This first connection definitely falls into that interesting category. This is the first use of a Heim joint that I've seen used in a stairway. In fact, I'll admit I'd never heard of a Heim joint before, but they're pretty cool. I don't know if I love this connection or hate it. I would definitely not enjoy having to determine the allowable axial tension on that hanger. I mean, I could do it, but it'd take me more than a minute. And if that's the kind of analysis that you want me to do, I can do that for all 12 of you who end up watching this and post it. So you can make a comment and say, hey, I want to see Heim joint analysis. I haven't looked into the materials of that thing, so I don't know about that one. So I can think of a number of ways to simplify this kind of a sort of free rocking connection for use in a real building, but it's not unlike hangers that I personally prefer when supporting landings. I'm going to get later in this channel to calculating hanger strengths and how to design all that. So anyway, look forward to that. This one is another interesting connection that the author tested. I had never considered including springs in stair designs, and I'm not sure that I will, but I liked the approach. It was interesting. I like this connection for allowing transverse movement at the base, but just as before, the author reports, in general, there was little transverse motion observed along the transverse slots. It seems to have also bound. Connections like this one are seen frequently in modern designs. But, once again, the author reports that during testing at lower amplitudes, the rotation was accommodated primarily through tolerance of the connections. In the larger amplitude testing, the rotation required deformation of the connected regions and the stairs themselves. In several of the larger tests, binding was observed. It was difficult to measure the effect of the binding or how much force was imparted back to the landings. My takeaway from this paper is that the code has required these slotted connections, and our industry has a very limited idea of how they perform in real-world earthquakes. More specifically, in this one paper, they seem to have not worked exactly like we thought. So, before I sign off, I just want to say what this video is not. I'm not trying to say that stairs in modern buildings are unsafe, nor that we should go back to the way stairs used to be designed. Slotted connections are code compliant, and I think that they're significantly better than previous stair design approaches. I intend for this video to be an opening for dialogue between our profession, be you an architect, an engineer, a contractor, and to figure out how to improve ourselves, our designs, and our buildings. Definitely with a focus on improving ourselves and the quality of our video content. So, if you're still watching, I'm willing to bet that you have some thoughts or questions. And I promise that I'm going to respond to every single comment left below this video, at least for the next couple of weeks. So if you have any questions, concerns, thoughts, just leave me a comment. I'm really interested to see what people think of this. Despite what most people think, when the big one hits in California, these floors are going to be the death of me.